All right, so welcome to the video on properties of logarithms. So here we will be using properties of logarithm to condense and expand logarithms. So the first part right here, we already have talked about this, okay? Those are two properties that we've talked about. So remember what we said here is that this is exponential form, right? And this is the base of the exponent, and then this is the base of the log. And I said if the base and the log of the base of the exponential function and the base of the log match, then we know, we've already proved it, that it's gonna be equal to that argument, which is u. And then the same idea here, base of the log, base of the exponential function match, it's equivalent to the exponent right there, which is u. And we actually can prove that even a quicker way today. Okay, and I'll show that to you once we get to it. All right, so here are 4 new properties that are very, very, very important and that we'll be using them all today. So we have to make sure that we know them. So this first one right here is the product property, and that is if you have log base b of, and then 2 things, 3 things, 100 things being multiplied, okay? So if you look at and you see factors, what you can do is you can break this up into 2 separate factors if it's, like this, u times v. And then what you can do is you can break it up into 2 logs that you're adding. So log base b of u times v is equivalent to log base b of u plus log base b of v, okay? And it's called the product property is because this is multiplication, and then you break it up into addition of 2 logs. Okay, next we have the quotient property, once again called quotient because we see division here. And if I said, guess what happens? This one was multiplication and it turned into addition of 2 logs. This is division and it turns into the subtraction of 2 logs. So once again, if we're looking at the argument here and the argument has division in it, you can subtract 2 logs, the log of the numerator minus the log of the denominator. Another way of looking at this is that the argument that's in the denominator, that's going to be a subtracted log. The next one is the power property. So if you see log base u of, and then there's a power on this log. So here's my log, and here's my power of n. What you can do is you can take that exponent, you can write it in front as a multiplier, okay? So let's really quickly, before we look at change of base, go back to this right here. If we looked at this right here, and we took this right here, and we used that power property and wrote it in front, we'd have u times log base b of b, and we've already talked about log base b of b being 1. So u times 1, which is u. So I was trying so hard not to say that in previous videos, and saying like, oh yeah, it's the power property, but here it is now, okay? And then lastly, we have the change of base formula. So the change of base formula says that if you have a log base u of v, let's say, that's equivalent to log of the argument divided by log of the base. Common log, that is. Common log of the argument divided by common log of the base, or natural log of the argument divided by natural log of the base. Now, why is this helpful, right? So let's say that we had log base 2 of 8, okay? This is asking us 2 to what power gives us 8, and it's 3, okay? But what if we had log base 2 of 5? 2 to what power gives you 5? Don't know. So what we can do is we can use the change of base formula to change this into common log of 5 divided by common log of 2. Why is that helpful? Because our calculator has a common log button, all right? We can just hit common log of 5, close the parentheses, divided by common log of 2, and that'll actually give us the decimal approximation. Well, it'll give us the exact answer. Well, it's rounded, it's a calculator, okay? So that's the change of base formula. And if we put common log of 8 divided by common log of 2 in our calculator, it would say 3. Okay, I'm gonna get rid of that because I don't need that on the sheet. All right, so 4 properties: product property, the quotient property, the power property, and then the change of base formula. Okay, so it says use the property of logs to expand each of the following. So what you're gonna do is you're gonna look at the argument and you wanna make sure there's no multiplication, division, or exponents left in it. So right here I see multiplication, so that means that I can split this into 2 logs. this is natural log, which could be any log here. So natural log of 7, and then remember for multiplication in the argument, you're going to turn it into 2 logs that you add. Natural log of x. Now, if you look at this argument and this argument, they have no multiplication, no division, and no exponents, so you know that it's completely expanded. You should also look to see if any of them you can evaluate. So if you did see, I already erased my log base 2 of 8, but if you did see like a log base 2 of 8 in your answer, you'd want to change that to a 3 because you could evaluate it. But if it was a log base 2 of 5 in your answer, you would leave it because we don't know what it is. Okay, moving on here. So here I see all multiplication, 10 times x times y. So let's go ahead and expand this. This is going to be this is all multiplication, so it's going to turn to all addition. Common log of 10 plus common log of x plus common log of y. This log right here we can't evaluate, right? It's asking us 10 to what power gives you 10, which is 1. So you have 1 plus common log of x plus common log of y. All right, next one, I see some division going on. So remember, I can turn that into subtraction of 2 logs. So I have log base 7 of 19, and then this is going to be minus log base 7 of x. Log base 7 of 19, 7 to what power gives me 19? No clue, so I leave it. All right, this one. I have no multiplication in my numerator, no multiplication in my denominator, but I do have division here. So I'm going to turn this into 2 logs that I'm subtracting. So I have natural log of e to the 3rd power minus natural log of 7. The second log is fine because there's no multiplication, division, or exponents, but in the first log, there is an exponent, which I can bring it in front of that log as a multiplier. Natural log of e minus natural log of 7. And then I would be done if it wasn't for this natural log of e. Natural log of e, remember, the base on this is e, so it's asking me e to what power gives me e, which is 1. So this is 3 times 1, which is 3, minus natural log of 7. So one thing to remember, I know that we know log base b of b is 1, but natural log of e is log base e of e. So just remember natural log of e is 1, okay? All right, this one right here. Ooh, I don't like where I put my answer to this one, so I'm going to move it over here. Okay. All right, this one right here, I have, if you look at the argument, there's an exponent, so I can take it and write it in front as a multiplier. So I have 2 times natural log of x. Can't simplify that any, so just 2 times natural log of x. This one right here, I see a square root, and I was like, I haven't seen one of those. So one thing that is, we're going to see a lot in logarithms is that when you have radicals, you can turn them into exponents. So let's really quickly off to the side here do a few examples in the middle of this lesson. So if I have the square root of a, that's equivalent to a to the 1/2 power. If I have the cube root of a, that's equivalent to a to the 1/3 power. If I have the 4th root of a, that's equivalent to a to the 1/4 power. See the pattern here? So I can rewrite this as log base 2 of x to the 1/2 power. And now I have that exponent. I'm going to take it and write it in front of my log. So 1/2 log base 2 of x. The most common mistake that people make and I make is forgetting to write your bases on these, like you want it to be common log, so just go back and check to make sure you didn't forget any of your bases. So base 2, natural log, base 7, common log, natural log. Okay, I did a good job. All right, next one. This says not next one, but next section, put these together. Okay, so this is all your properties. Just try it out, okay? All right, so here I see a bunch of multiplication. That's 2 times x squared times y. So I can break that into 3 logs that are being added. And then I also see an exponent, and I'll cross that bridge when I get to it. So this is going to be log base b of 2 plus log base b of x squared. And then I know that with that exponent, I can take it and write it in front of my log as a multiplier. That's why I left space there, because I knew that was going to happen. Plus log base b of y. If you look at each of your arguments have no multiplication, division, or exponents left in them. So you're good to go. Oh, I should see if I can evaluate any of them. The base is b, so I'm not too hopeful on that. And I don't see any log base b of b, so no. All right, next one. All right, okay, so here, first things first, I see that there's a cube root in my numerator. So I'm going to rewrite this as x to the 1/3 power, all right? I don't want to deal with that cube root, right? X to the 1/3 power. Okay, so I'm going to go ahead and start writing this. So I'm going to put an equal sign here. Log base 6 of x to the 1/3 power, but instead of writing it to the 1/3 power, I can write it in front as a multiplier. And now everything that I have now is in the denominator, so it's all going to be subtracted off. Okay, I'll re-explain why after I'm done doing it. Minus log base 6 of 36 minus log base 6 of y to the 4th. And since it's to the 4th power, I'm going to put the 4 in front as a multiplier. Okay. Now, I can still simplify that log base 6 of 6, which I'll get to in a second, but people always ask, like, why is this not plus? All right, because this is multiplication right here. Well, yes, it is, but it's all in the denominator, right? So this has to be in parentheses, and then you can't leave your answer like that. You have to distribute your negative, right? So another way of looking at it is everything that's in the denominator is subtracted, okay? So getting back to evaluating this right here, we can evaluate. This is asking us 6 to what power gives us 36, which is 2. So we have 1/3 log base 6 of x minus 2 minus 4 log base 6 of y. And there is your answer. Looking at your arguments, your argument here is x. This is not even a log, so I don't have to worry about it. This has a y. I'm good to go. All right, this next one right here, I have 5 times. This is an x to the 1/2, right? And then 2y cubed. Okay, so now I'm going to start breaking this up here. So I have log base 2 of 5, multiplication, so plus. Log base 2 of x to the 1/2, I can bring that exponent in front. So 1/2 log base 2 of x. Now I'm in the denominator, so I'm going to go minus log base 2 of 2. Still in the denominator, so minus log base 2 of y cubed. So I'm going to move this over. Instead of putting y cubed, I'm going to put the cube in front of that. And then I heard myself say log base 2 of 2, all right? 2 to what power gives me 2? That's 1. So I want to change that to a 1. So log base 2 of 5 plus 1/2 log base 2 of x minus 1 minus 3 log base 2 of y. And remember, you can't do anything with that minus 1. Not remember, but realize you can't do anything with that minus 1. It's not a -1 minus 3. It's a -1 minus 3 times log base 2 of y, right? They're saying there's 3 of them. All right, next one, there's multiplication happening right here. So I can break that up into 2 logs that are being added. And then this right here, I can rewrite as x cubed plus 2 to the 1/2 power. Right? Okay, so we have natural log of x squared, but I can rewrite the exponent in front. So 2 natural log of x, multiplication, so plus. Natural log of x cubed plus 2 to the 1/2, but once again, I can write that 1/2 in front as a multiplier. Natural log of, and then I want to make sure I keep that x cubed plus 2 in parentheses. So I know that it's grouped together, and it's like that's the entire argument. So people will be like, what about this exponent? This is the argument right here, right? It's not, if it was out here, I'd have to get rid of it, but not inside. Okay, all right. Okay, let's look to see what we have next. Next here, we have write each in terms of A and B. So all of our answers here we want in terms of A and B. When we're done, we should be left with just A's, B's, some coefficients possibly, and addition and subtraction. Okay, that's it. All right. So here we have common log of 18, and it said, oh, sorry, let's read the directions. Let A equal common log of 3 and B equal common log of 6. Write each in terms of A and B. So people tend to say, oh, 18, 3 times 6, A times B. And it's like, this is not just multiplication, right? We're using properties of logs, okay? So first what you want to do is you want to say, how can I use a 3 and a 6 to get an 18? Yes, that's multiplication, so I can rewrite 18 as 3 times 6, right? But then I say, oh yeah, multiplication, I can break that into 2 logs that I'm adding. So that's common log of 3 plus common log of 6. And now I can replace the common log of 3 with an A and the common log of 6 with a B. So I have A plus B. Most common wrong answer, A times B. Because people will be like, 3 times 6. It's like, no, that's not how it works. All right, next one. How can I use a 3 and or 6 to get a 36? So you can either say 6 times 6 or 6 squared. I think 6 squared is more condensed, I should say. It's not more precise. Okay, so I have common log of 6 squared, and then I can bring that 2 in front as a multiplier. So that's 2 times log 6, and then log 6 I can replace with a b, so that's 2 times b. If you would have said 6 times 6, right, 6 times 6, then you could have done common log of 6 plus common log of 6, which is b plus b, which is 2b. Wow, all right? So it's like you're going to get there either way. All right, 54. I got to think about this one, right? So common log of, I got to use 3 and 6. So 9 times 6 is 54. So I know it's times 6. 9 times 6 is 3 squared. So 3 squared times 6. All right? So that is 2. Oh, I should go like this first. I can break it up into multiplication. Common log of 3 to the second power, so I'll bring the 2 in front, plus log 6 is equal to 2a plus b. And once again, if you're getting there in a different way, but you're still getting there, it's fine. This one right here, 1/2. So how can I use a 3 and a 6 to get a half? I got it. So this is common log of 3 divided by 6. And then I can do common log of 3 minus common log of 6, which is a minus b. Most common wrong answer, a divided by b, right? No. All right, using a 3 and a 6 to get a 2. Using a 3 and a 6, division, right? So this time do 6 divided by 3. So this is just log 6 minus log 3, which is just b minus a. Most common wrong answer, b divided by a. Okay, next one, common log of 1/3. So I can rewrite 1/3 as 3 to the negative first power, right? It's not the only way to do it. It's just the fastest, right? I could say, I could get 1/3 from doing, let's say, I'm trying to think of another way that people might say 3 over 3 times 3, right? 3 over 3 times 3. Which works, 3 over 3 squared, right? And it'll get you there, but this way is just faster. Okay, so take your exponent right in front, -1 times log 3, -1 times a, which is negative a. Love those. They're like little puzzles, okay? All right, next we have write as a single logarithm, so condensed. So this is the vice versa of this. So it's like if I gave you this and I wanted you to give me this, all right? Okay. So let's go ahead and do that. So for this, writing it as a single logarithm, you just want one log as your answer. So you want, this one is common log, the next one is common log, the next one's common log, the next one's natural log, the next one's log base b. You want to write it once, okay? All right, so then you look and you say, all right, I'm going to condense this. This is addition, which turns to multiplying the arguments. So you're going to multiply your arguments. And then that is common log of 100, which if you couldn't evaluate it, you'd be done. But since we can't evaluate, we're going to evaluate this. This is asking us 10 to what power gives us 100, which is 2. All right, next one right here. We're going to write this as 1 log. We're condensing it. Subtraction means that there's a denominator. Everything that's positive, the argument goes in the numerator. Anything that's behind a minus, the argument goes in the denominator. So this argument is in front of a positive log, so it's going in the numerator, the argument that is, 7x minus 6. This argument has a minus in front of the log, so it's going in the denominator, x. And then there is your logarithm condensed into 1 log. All right, next one. Once again, this is common log. I do not see, these 2 logs are being added together, so no numerator denominator, okay? All right, so this argument is x, but notice there's that 1/2 multiplier on it, so I'm going to write that in as my exponent. So that is x to the 1/2 power, which you can write as square root of x, or x to the 1/2 power, I don't care which one. And then this is multiplication, this is a 4th power. So this is x minus 1 to the 4th power. And this right here, we should put it in parentheses to show that it's all together, is your whole logarithm. All right, natural log. These are being subtracted. So this right here is in my numerator, x plus 7 cubed. This is in my denominator, x. All right, next one, log base b. I see minus, I see a minus here too. So those are going in my denominator, so that means there is a denominator, right? This has a plus in front of it, it's positive. So this is going in my numerator, that's x to the 4th power. This has a minus in front of it, so this is, this is going in my denominator, but this is an exponent here, so there's a 36 in my denominator. And then the last one has a minus in front of it, so it's going in my denominator. This is a 1/2 power, or the square root of y in my denominator, because it's got a minus in front of it. Okay. Let's see, last one, log base 3. Okay. All right, so here's the first thing that I notice. Let me move this over here real quickly. Here's the first thing that I notice. Actually, let's pretend like I don't notice this for a second, okay? I'm going to say I don't notice what I do notice. Okay, I'm going to do it the same way. This is positive. This is going in my numerator. And I know there's a denominator because I see a minus right here, right? So 4. This is a negative log. The argument is x. This is a square, so x squared goes in my denominator. The next log is positive. It's going in my numerator. The argument is y. It's not y plus 2. If the argument was y plus 2, it would look like this. So the argument is y, so y to the 5th is going in my numerator, but then I have this plus 2 on the end, okay? So the problem is that this isn't a log. I know that there's this log right here that goes in the numerator, but I need to turn this into a log, okay? So what I want to do is it has to be equivalent to 2. So the only thing that I can think of, well, not the only thing, but one thing that I can think of is that 2 times 1 is still 2, so I need a log that is equivalent to 1, okay? A log that is equivalent to 1, I'll give you as many examples I can think of right now. Log base 2 of 2, log base 3 of 3, log base 4 of 4, log base 5 of 5, log base 6 of 6, so on and so forth, right? Those are all equivalent to 1. I want to use log base 3 of 3 because the base is already 3 here. So we're going to write log base 3 of 3 right here. Okay? And now I can take this This is my positive log. So when I write the argument, it's going to go in the numerator. This is 3 squared, which is a 9. So there's a 9 going in the numerator. So times 9. And now I can clean that up. Because 4 times 9, I want to actually see what that is. So log base 3 of 36 y to the 5th over x squared. Okay, last but certainly not least, we have the change of base formula. I kind of already talked about this, but let's see if my calculator is up and running. Please, pretty please. Of course not. Oh, there she is. She's fine. Okay, so let's say I didn't know. Well, I do know what it is, but log base 2 of 8, okay, is 3. We already know that. But the change of base formula says that you can take the common log of the base, which is, sorry, the common log of the argument, which is 8, divided by common log of the base number, which is 2. And that, so common log of 8 divided by common log of 2, that will give you your answer, 3, right? So find the value of log base 3 of 17 using the change of base formula. We're going to do common log of 17 divided by common log of 3. And then we'll get a decimal approximation. So common log of 17, close the parentheses, divided by common log of 3, close the parentheses, hit enter, and we have 2.579. And that's a decimal approximation. And then what you could do to check it is you can say 3 to what power? 2.57890, blah, 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 blah. All right, so I'm just gonna go grab it. That, okay, is equal to 17. All right, this one, common log of 85, or you could use natural log if you want, because there's a natural log button too, of divided by common log of 6. This one we're gonna do common log of 2/9 divided by common log of 5, or you can use natural log, it doesn't matter, okay? Common log of e divided by common log of root 2, okay? So we're gonna get a decimal approximation. I don't know why I can't make tildes to save my life. Okay, tilde, oh gosh. Okay, common log of 85 divided by common log of 6, 2.479, and watch natural log of 85 divided by natural log of 6. Same answer. 2.479. Log of 2/9 divided by log 5. Negative 0.935. And then last one, common log of e divided by common log of square root of 2. Oops. And we get 2.885. Okay, that's it for today. Please realize, actually, that's not it for today, because if I go back up to this one, I can make up another problem right here. If I did log base 3 of 6, you could now do another problem using change of base. You can say that's common log of 6 over common log of 3, which common log of 6 was b. So that is b over a. Just want you to see that, okay? All right, that's it for these notes. Hopefully you can get some problem done on your own now.